In this video, we'll discuss about electric field strength at a point on the equatorial axis of a dipole. In the previous video, we discussed about what is the electric field strength, how to calculate the electric field strength due to dipole on its axial axis and a point on its axis, dipole axis. Okay, here it is a dipole, say minus q. Let us write it as this point as A. Here it is a dipole. We'll write this point as A minus q charge, and we'll write this point as B. Here plus q charge is there. This is a dipole. Length of the dipole is 2L, and this is center of the dipole. We'll take as O. This is L, and this is L. On the equatorial axis, take here a point N. So at N, what is the electric field due to individual charge? We'll calculate due to minus q at N, due to plus q at N. See, if you want to find out the direction of the electric field intensity or direction of the force at a point N due to any charge, at that point you assume a unit positive charge. So that unit positive charge is attracted by negative charge minus q. So the direction of the electric field intensity will be towards A. The direction of electric field intensity will be towards A, that is from N to A. This is the direction. This will write as E minus. Similarly, this plus Q will repel that unit positive charge placed at N. So direction of electric field intensity is in the direction from B to N. Draw a line along B to N. That is the direction of the electric field intensity. So at N, due to plus Q, the direction of electric field intensity is this. We can write E plus. It is directed from B to N. So what is the net electric field? So just simply construct a parallelogram using these two components. The diagonal of it, that parallelogram gives the resultant of these two fields at N. So this is the direction of net electric field intensity E bar due to dipole or the electric field intensity at equatorial line at a point on the equatorial line of the dipole, that is at N. So if what is the length, what is Bn here? If you take L and N say at a distance R, then Bn length will be L square plus R square. Similarly, An length also, isosceles triangle is formed. Then obviously this angle and this angle will be same. That means what? This is also theta, this is also theta. Now you resolve the E plus into components, that is which is acting along Bn. If you resolve into components, okay, this one becomes E plus sine theta, and the horizontal, this thing will become E plus cos theta. So here I am writing E bar, the net electric field, as E plus cos theta, one component, because it is acting along horizontal direction. The combination of the sum of those things gives the net electric field intensity. And we'll resolve E minus also into component. E minus, this component acts vertically downward. This component is E minus sine theta. Both cancel each other. E plus sine theta and E minus sine theta cancel each other. What is the vertical component? What is the horizontal component? This is the horizontal component. The horizontal component of E minus is along the diagonal of parallelogram. Okay. So these two are acting in the same direction. Therefore, the net electric field E bar we can write as we'll take magnitude. We can write as E plus cos theta plus E minus cos theta. What is the value of E plus? Let me write here. What is the value of E plus? Magnitude of E plus and magnitude of E minus will be same. how much? KQ by distance square. What is the distance from B to N or A to N? Same distance. So R square plus L square root power square, root will be get cancelled. And what is the cos theta in the triangle? What is cos theta? Adjacent by hypotenuse. L divided by root over L square plus R square. So if you substitute here, both are same. E plus and E minus are same. So E plus cos theta plus E plus cos theta, you will get 2E plus or minus whatever cos theta. Let us substitute equation. What is KQ by R square plus L square into what is cos theta? L divided by root over R square plus L square. Okay. So this is equal to 2 here 2LQ into K divided by this becomes R square plus L square power 3 by 2. So 2LQ nothing but what, Nana? Dipole moment. So dipole moment is what? P bar equal to 2LQ. The dipole moment is. So K into P divided by R square plus L square power 3 by 2. This is the net electric field at a point on equatorial axis. If you kept this system in air or vacuum, if it is in any medium, simply divided by its dielectric constant. Okay, here we'll see one important point. The dipole is taken like this, that is the direction of the dipole moment is this p bar. On the equatorial point, if you just recollect what I said now, on the equatorial point, on the equatorial axis, at that point n, the net electric field acting in this direction. This is the direction of the net electric field, that is electric field on the equatorial axis. What is the dipole moment direction? Say along positive x-axis. What is the direction of electric field? It is in the opposite direction. So here very on equatorial axis of dipole, p bar, that is dipole moment, is anti-parallel. Both are mutually anti-parallel. P bar and electric field intensity both are mutually opposite to each other. This you remember, very important. So here another point we'll discuss. In case of short dipole, that is if the length of the dipole comparative to the distance of the point, reference point, that is R, say is greater than the length of the dipole, then we can neglect L square in the equation. In the equation of electric field, we can neglect that L square. If you neglect, you will get K into P divided by L square. If you neglect, R square power 3 by 2, that is R cube you will get. So this is one important equation. You remember this, and based on this also we can do a few more problems. Okay, we'll see in another video what is the effect of electric field when a dipole is placed in it. Okay.